I'm here again at the University of Copenhagen on a beautiful afternoon with a light breeze, surrounded by sunshine on our beautiful planet, with Lena Noack, who is a planetary scientist at Freie Universitat in Berlin, who was one of the featured invited speakers here and gave a great talk on the range of habitable planets that could be out there, which is a very controversial topic and still speculative. But the name of the conference here is "Are We a Unique Species on a Unique Planet?" And we've been discussing in the interview here with Lena about what makes a planet habitable. One of the things is plate tectonics, liquid water at the surface, how to spot biosignatures and abiotics. We need a better understanding of abiotics in general to be able to actually look for biosignatures. But in the conversation, Lena, you said something interesting to me, which I hadn't heard recently, or maybe never, was that Venus, Venus, which we think is a hellish planet, we know is a hellish planet, and has very little, almost no water on the surface, detectable water on the surface, you say has quite a bit of water in the mantle, in the interior. Is that correct?
Yeah, that's something that we actually believe based on the fact that we actually still have a little bit of water in the atmosphere right now. So if you imagine that Venus would be completely dry in its interior, no matter if it ever had a liquid ocean at the surface or if this was never the case for Venus, whatever water is in the atmosphere or was ever in the atmosphere should have been lost very efficiently to space. We know this since actually like a decade. Venus Express measured how fast hydrogen is actually lost from the atmosphere of Venus today. Mm-hmm. So to actually still have some water in the atmosphere of Venus today, we need to wonder where it comes from. And the easiest explanation is we know that Venus is still volcanically active, that regularly water from the interior is actually pushed into the atmosphere. But this will never be liquid at the surface. It's just too hot for it. So whatever is volcanically outgassed is just water steam in the atmosphere, and then is again lost to space.
And you think that Venus, unlike a lot of people, a lot of researchers, you personally think that probably you're speculating a bit. Venus was never ever habitable. It was always pretty much of a hellish planet, even early in our solar system's history. Is that correct?
So I think it's one of the big drivers in planetary science that we want to understand, was Venus ever habitable or not? The thing is that for now we really don't know. So I think we find the idea that Venus may have been habitable early on very attractive. But I personally think that everything that we see on Venus nowadays, no matter if it's the atmospheric composition or also if you take into consideration the orbit of Venus, everything is much more easily explained by a body that was always hellish like today. So that's the atmosphere that we see nowadays, almost 100 bar CO2 atmosphere, may have been around since the accretion of Venus and since the magma ocean stage. And this never would have allowed for liquid water at the surface, but we don't know. This is something that we all want to find out.
But what do you think? I mean, personally, I've always been fascinated by Venus, and as a kid going out and looking at Venus, and it's such it's our sister planet, and obviously it went hellishly wrong. Does that give you pause? I mean, it's within our own solar system, we live on a veritable paradise. I mean, a beautiful Earth, a planet that we need to take care of, and then just one planet over, our nearest neighbor, even closer than Mars, and we spend all this time looking at Mars, very little time looking at Venus.
Well, this is changing now. Everyone is looking at Venus now.
Everybody's looking at Venus now, but we're still waiting on the missions.
Yeah.
But I mean, from a scientifically and slightly philosophical point of view, it's kind of haunting that the next planet over is so uninhabitable.
So what's more haunting me is actually, why is Earth not? So what exactly did go right for Earth which maybe did go wrong for Venus. And so I think it's easier to understand why Venus may have always had this hellish phase, this dense atmosphere, no possibility for liquid water at the surface. But then why did it change for Earth, and how fast did it actually change? And I think we can be very lucky that whatever happened in the first few tens of million years on Earth, which led to water actually condensing, building an ocean, and allowing us to not have a dense CO2 atmosphere, is something that we should be very happy about, that we have it for Earth.
Well, thank you so much, Lena. It's been a pleasure. Thank you for taking the time to speak to us.
Thank you.